This is the pattern stimulation microscope, and this is a description of starting the system up and then doing simple 2-photon imaging and 2-photon patterned illumination. At the heart of the system is the Thorlabs Bergamo microscope, and you see that right there. We at the moment are using an objective, 16x objective. That's pretty common. Our sample stage, because we're working with either in vitro samples or slices or cells, is this guy right here, and that's under computer control. And I'd like to explain a couple of the parts. The microscope is set up to operate primarily as a 2-photon microscope. To do that, we have this primary dichroic, which we push that in. That deviates any fluorescence to go up to these two PMTs. And in combination with the resonant galvo scanning, which I'll show you in a moment, that's going to sweep the point across the surface. The light will be collected by the PMTs, and in software that's put together to create an image. The other way is to take the dichroic out. The fluorescence would go up, and there's appropriate filters for looking at, say, red fluorescence and discriminating against the IR. And that goes up to a camera, and in our particular case, this is an Andor Neo camera. And that's pretty convenient because we've used that for simple things, but also for doing high-speed imaging of voltage Voltron, for example. The control over this laser is pretty simple. There are parts that are accessible through some devices like the knobs here control the sample stage, and then this is for controlling an LED, and that's for doing 1-photon imaging. So that LED is back there. That's a 525, and this is a dichroic that functions to bring the light down, and then the fluorescence that comes up is going through filters. There are also a couple of dichroics which bring the imaging beam, the 2-photon imaging beam, at 920 nanometers. That's this lower dichroic. And then this upper dichroic is for bringing in a photostimulation beam. That's at 1030 nanometers. And I'll just tape that on for the moment. Okay. So what I would like to do is explain, it's pretty simple to turn the system on, and if everything is working, then it's easy to do imaging, 2-photon imaging, pattern stimulation. And so what I'd like to do is to just describe 3 simple things for turning this whole thing on so that you could do some imaging. And the first thing is to turn the lasers on. The second thing is to open the software, and then the third thing will be to create a sample. And then to go ahead and I'll show you how to do the controls on the software. Let me just show you the picture that I drew from a PowerPoint, which is just a layout, sort of functional layout of the system. So our sample would be right on this surface here. In the past, we've done some electrophysiology in combination with some other imaging or photostimulation. There's some diagnostics that get used down below. You wouldn't use this, or you wouldn't have this, if there was an animal at the sample plane instead of just a dish of cells. We have a camera at the side just to look at what's going on. That was, I found, convenient when I was doing electrophysiology to see where the pipette was. This is right here, the primary dichroic, and that goes in and out, and the light could go over to the PMTs, the fluorescence light, or go straight up to the camera. The source of light, blue is sources of light, is the 2 lasers I have here. This is a 920, and I'll show you that in a moment, and then this is a 1030. One is for photostim, 1030. One is for imaging, that's 2P imaging, and we use raster scanning through a resonant galvo scanner. Photostimulation is done using, in all cases, an SLM. That gives us a pattern. That's how we create patterns. We use 2 methods where we have 2 beam paths. One is temporal focusing, which is also known as 3D shot, or spiral scan, and that's typically what people use. Okay. And we have as I said, an LED, it's 525 at the moment in the back, and that's the layout. Okay, so let's turn on the lasers, and in the back is the Chameleon Ti-Sapphire laser. It's operating at 920 nanometers, and the power supply for this is down below, and I've already done it to warm up the laser, but turn it on, you turn that key to the right, and then there's a shutter button right here, and then when you just press that in. Okay, and then you can see, you could always check that it's running at 920, and if you needed to adjust that wavelength, you would just change it, hit menu select, and the laser would go to 884, and you would operate there. And then if you didn't like that, you would go back to 920. Oop. And menu select. Okay. All right. So we come up, and because this laser was turned on a little earlier, we should have a beam. This is a nice IR card for looking at IR beams. Okay, so we have a couple of mirrors for steering the beam into the Pockle cell. So the Pockle cell is an attenuator, and it's actually a modulator, and it's rotating the polarization. Then there are some polarization optics to pass or not pass light, and so you can see a pretty bright going in, really dim going out, and that's sort of set at the minimum. And then we use that to modulate the intensity of the 920 nanometer light. Okay, and then a couple of turning mirrors, beam expander. We come up with this periscope, and we come into the back of the microscope, and this is the scanner, the resonance scanner, all Thorlabs products, and then the beam goes on from there. Okay, and that it's pretty simple. I don't know that I need to show this, but anyhow, so the scan head that I was just pointing to in the back of the microscope, the beam would then go through a scan lens to collimate the beam into the tube lens, which will then bring the beam down to the objective through this dichroic. This is a movable dichroic, and of course I have this primary dichroic, which is movable also to bring fluorescence to the PMTs. Second laser is this Monaco 1030 nanometer laser. This is made by Coherent. This is also, the Chameleon is also made by Coherent. And the power supply for that, and again I've turned this on earlier, would be underneath, and it's this key right here. Turn that to the right. Alright, and then on this computer there is software. This GUI is the control for the Monaco, and you would initially click start and wait 15 minutes or so. There's a temperature stabilization, and then you can click on and then for pulsing, so click that on, and then you would open the shutter, and it always gives you, are you sure you want to do that? So I click OK, and let's see how the triggering. So nothing's going on. We set this up for internal or external triggering, and so at the moment there's no output. All right, so I'll just quickly show you the beams for that. So let's go back to triggering. We want this to be internal, and okay, that's open. And then you would have to select a power level, and the power level is typically a few percent of RF, and so I'm going to put in 2%. Okay. All right, and if we have our IR card out, let's see, we can come down here, and there's the beam. There's some other mirrors here. We have a collinear helium neon laser, which is pretty convenient, and I'll use that in a moment, but I just wanted to show you the IR beam. So it's down there, and then brought up by that mirror to this turning mirror up top here. And then there is a wave plate right here, and that's to bring the alignment of the polarization to be vertical. So that's what the SLM is going to want. And then there's a beam expander, and this is the first lens of the beam expander, and this is the second lens. And then we've gotten to the point where we can't see the beam. So I could turn out the lights, or I could just use the Heaney, which is a little more convenient and actually a little safer. So I can turn this, that's the shutter for the 1030 nanometer beam. Okay, so the beam goes over here to this turning mirror, through this iris, and to the SLM. And the SLM is this guy right here, and that's the face of it right there. And let's see, yeah, okay. And then it reflects. Right now, it should be set for 0 phase, so it's reflecting the beam as a mirror would, and then the beam goes. Remember, this would be the path of the 1030 nanometer beam through this focusing lens. So the focus is somewhere about there. This is the secondary focal plane, or image plane, I should say. And then that's going to be relayed to, in this particular setup, this is for spiral scan illumination. And to create a spiral, we're going to use a Galvo. This is a Galvo scanner. And the beam goes in. Oop. I see it. Into the back, through the top, and then, as you can see, or maybe you can't see, I could see it, the red light. Yeah, okay, so that's where the IR would come in, the 1030 beam, and create the pattern stimulation down at the sample. Okay. So we've turned on the lasers, and the next thing to do is to turn on the software. So I may refer to these again, pictures. So let me minimize that. And to open the first of the several software, this is an easy one. This is the MCM 3000 software for controlling the sample stage, which is this guy here. If you were doing an animal, you probably wouldn't have that. You'd have something else. And these knobs here are X, Y, and Z, which is, you have two ways of doing this, through software or the analog control. And then you just have to click OK for the port number, and that's the software GUI. And you've got these sliders for setting the position and step size. I always choose fine for those. And so you can go up or down in incremental steps. That's a micron. Or you can do it through using the dials. Okay. And so that is that software. And then I want to open the scan image software. And so to do that, we will go to MATLAB. It's pretty slow. Type in scan image. And then you can minimize scan image, or actually you can see start scan image, and then it'll go through some series of steps, and if there's some problems, you'll see some red lines which will indicate errors. May or may not be fatal errors. Okay, if it gets to this point, it's fine. So I'm going to minimize MATLAB. This will all get rid of itself shortly. All right, not a good use of time, so let's open one other software package. We want to control, or at least use, that camera. And so it's an Andor Neo, and we have an Andor Neo Solus software, and that's this right here. But let me wait and just move these different scan image windows. Let's put this over on this screen. Let's pull up. These are going to be the windows, channel 1 and channel 2. And we're going to set RG gray. So channels 1 and 2, channel 1 is red, channel 2 is green. Okay, and so that's just going to give this some color. Okay, there's a number of features. If you're familiar with scan image, then this is all common. If not, then I'll just explain what you need to do. But I would like to open this other final software package, which is the camera software. Okay, so to turn on the camera, you click this real-time button, and to turn off the camera, you would abort acquisition. So it's this, and of course there's nothing, and then abort is this. And then the other key thing is that you want to control is exposure time. And for the moment, let's just leave this here. Okay, all right, so the laser's on, the software is on. And so if we've gotten to this point, we're now at the sample stage. This could be a couple of things. It could be cells. It could be tissue. At the moment, we're just going to do simple in vitro dye film with a Sharpie. It's a fluorescent neon orange Sharpie. And this was yesterday's sample, so I just want to redo it. You can start fresh or not. Okay. Just going to clean that off. And then you could also do the same thing I'm doing in a dish. Okay, and then we could put a dish on rather than a slide. And so the dish is a little more convenient for the reason that you don't have to worry about water running off of the sample or the slide. I just usually wipe that off and give it a second. All sort of superstitious. Now, let me make this a little tighter because I want to rub in some lines. I want to give this some structure. Well, maybe that was rubbing a little too much. All right, so let's not. Well, I'm not happy with that, so let me do this one more time. And let's try this. Okay, that's more like it. All right, so that's our sample. And as I said, we could have done that on the glass surface here. We might need to squirt a little bit of ethanol and clean it first to make for better adhesion. And then we can stick this under the microscope, and conveniently the height is going to be pretty close. That is, the sample height to the objective is going to be pretty close to being right on. Now the only other thing I need is some water. And let's see us do this. Okay. So it could run off. Sometimes it does. Okay, but this time it didn't. And we have this camera over here. That's a FLIR camera, and it is looking at the objective from the side. And that's convenient when, for example, well, just convenient now for, and as an example, but also when I was doing electrophysiology. So it's there, it's useful. Okay, so let's turn on two things. One, let's give it some light. Remember, that's this controller right here, and it's the switch in the back. So we just leave the setting for the power level set. And then it's not too visible, but it's there. And then the other thing is this dichroic has to be out, which it is. So light is coming down. You can see light there. Okay, and I guess I'm going to dim some of these lights. And so let's dim this. All right, and now we're going to run the and/or Neo. Okay, and so let's adjust the Z of the sample. Okay, and we could go scoot around. Okay, and we can turn this up, and we could illuminate with more light, or we can, with this guy, change the brightness. All right, so we've got a surface, a sample. Ideally, that would be cells in culture, or otherwise a tissue. It would be much more complicated if it was tissue, but anyhow, we would get this set up. I would get it set up in the green excitation, 525 excitation. Okay, so the next thing is to do 2-photon imaging. So we need to turn the light off. So we do that, of course, with this control. And then we want to push in the dichroic. So, of course, we're going to send the light up to the PMTs. Now, I want to turn off and make this darker. That's not actually good enough. And I guess I could show you that. Let's first get this out of the way. We're going to put this over here. And we'll bring this widget bar window back. And this control window controls the intensity of the screen for the camera. Okay, what we would do, because of the way we're set up, is we would just click focus, and that'll turn the PMTs on because I've got this auto on clicked, and they are already set up so that this should just look fine. And so we'll do that. And what you're seeing is undoubtedly just the artifacts of the light, the room light, or the screen light from here. So let me stop and make that. That was sort of making the case that we need to put some kind of black cloth or have this in a dark box. When you're building a system, you don't really need to put something in a dark box. So what I'm going to do is to shroud this with a black cloth. That's easiest. And okay, see a little bit of scattered light. I'm going to turn that helium neon laser off. That's this guy over here. Let's try this again. And to go to focus. All right. So let's turn the power for the 920 imaging beam up. Okay, that's 1%, and that's not bad. Let's go up to 2%, and that's not bad either. Let's auto scale and auto scale, and I just want to put that in the front. Now we can move around the position of the laser. I am moving to do this, I'm going to move the piezo. I'm going to move the objective using a piezo. And so the objective is mounted on a piezo mover or transducer. And so let's just do step size of 1 micron. And let's go up. And let's go down. Okay. Alright, so that's maybe a little bit better. This is at +2 microns. There's a couple of things we can do. We could certainly turn up more power. We could try that. Alright, and then we can again auto scale. And again auto scale. So that looks like, I'll move the sample. That's just a bright part of the sample, which is fine. And we can do a couple of things. We can do frame averaging. This is not always the smartest thing to do, but okay. And so definitely makes the red look better and the green not so good. And then as you're looking at this, you can say, hey, what's that jagged line? And so typically what you need to do is to adjust this. We're doing scanning in the forward and backward direction. That's because we clicked on it, or was clicked on bidirectional scan. And so usually you have to tweak that. The best way is to just click auto adjust. So let me do that and you can watch. Okay. Not great. So I'm going to go in and, okay, that's going to be worse. Okay. And there we go. So that's better, and auto adjust couldn't quite get that. Maybe one more. This is going down, or the numbers are going up. Okay, so I like that. There are other things we can do, and so I'm going to turn off the frame averaging, and we'll have to probably redo. Let's see. It's not bad. Could, if we needed to, redo that, the forward and backward. I just want to turn that bidirectional off, just so we could run that way. That's much better. It doesn't have the interleaving effect, but the price we pay is to run it 15 frames per second. And so the other thing that we can do is we can turn this off for a moment, and we can run it 1,000 pixels by 1,000 pixels. It's 1,000 by 1,000 because we've chosen the pixel to be equal to the line, so 1,000 lines, and then we're choosing square pixels. And then we can do focus. And again, this will take the frame rate down to 15, and then we can zoom in and sort of see, do we like that? Okay. Alright, so let's go back. Port 512. And then the other thing we can do is we can zoom in with the galvo, the maximum angle of the galvo, and this would be of the Y galvo. Let's just go up 4. And then this affects just zooming in. But at this nice 512 by 512. So this might be 4x, might be on the zoom for the galvo, might be something you'd use if you had a cell or 2 cells and you wanted to look more closely to, say, resolve subcellular structure. Okay, and so there's not much else I can say at the moment. That's the fundamental idea behind the imaging. We're going to abort. Let's put this back to 1. Go focus. And abort. All right. The next thing I'd like to, so we've turned on the lasers, we opened the software and got all that running, made the sample, and we got it lined up and imaged with 2 photon light. And so the last thing for this video is to do pattern illumination. So to do that, this is the SLM controls. And if you close it, this is always available from the view window. Go down, SLM controls. Now I want to look at the show phase mask. And for reasons that are related to the alignment, this is not 0 at the moment, but it will be, or very close, when I put in the park coordinates. Okay. Okay, it's not quite 0. The 0 phase is going to look, if you bear with me a moment. Oop, you saw it. There it is. Okay, that's the phase written to the SLM, and this slowly varying phase is it's a distortion accommodation. The SLM chip is slightly curved, and so to accommodate for that, there is a file which is the wavelength dependent distortion file, and that's what this is right here. So the idea is that a collimated beam incident on this phase mask will remain a collimated beam. Okay, so this little GUI is not 100% useful, but it's pretty useful. So let's bring the camera. The way we're going to operate is to use the camera for a lot of this work, and so to do that, I've got to go back. And actually, when working with this to camera, I don't need the darkness that the PMTs need. And so I can actually put on a little bit of light here. Okay, so at least we can see something. Okay, and then I want to remove the primary dichroic so the light will go up to the camera. And if I just start clicking, okay, nothing there. And if I turn on some light, that's that. And we can auto scale or just bring that down. And that's just a reference point. And then what I would like to, maybe I should stop that. Okay, no, actually, let's keep that running. And the first thing I want to do is to open the shutter. Remember, this is running at about 2%. And this is the 0 order beam. And that is what you see there. If I turn off the 525 light, it's all by itself. Okay, now this is under control. This beam, let me show you that. The light's coming off here. You can't see that. I can't see it. You can kind of see that. Okay, and then there it is there. Let me come up. Okay, and it's just this image plane that's being relayed over to the sample plane. Okay, and so now in this GUI, it's very convenient to just move that beam. And what you see is the beam is moved, and there's a little bit of 0 order beam. That's the undifracted light. Okay, so let me put that over there. And you can go to a point on this side and right click, and you can just add a point. As you can see, I did, and do that again, add a point, and add a point. Okay, there is some, this is one of the bugs, this is not properly relayed, in rotation and for this GUI. Okay, but the idea is simple, right? You can just draw points and that is your patterned illumination, or if you've got cells that have opsins, it'll be pattern stimulation. All right, so let's park this. SLM park. And let's set up the triggering so that we have the laser running not free but under control of the software. So let's close this, turn that pulsing off, go to triggering, click enable, external gate, click enable external energy control, power control, turn pulsing back on, and then open the shutter. All right, now nothing is coming out. You can see that at really low level. And I'm going to move this and move this for the moment. And I want to open what's called the photostim controls. And so what you want to do is click that. And you want to go new, edit. This is the way that we're going to control the SLM spots as well as the galvo scanner. Okay, we could, if we had a field of cells, just click on live image and that would bring in channel 1 or channel 2 and we would see where the cells are and then we would start drawing points on those. So let's see if we can just get started here on it. I've got this right. Add ROI. And let's go. Oh, right. Okay, so let's set that. I should have set that at 0. Okay, and I want to create a pattern. So I want to add points. I don't want that at 2. I want that at 0. I want the Z-plane at 0. That's being set at 2 because on the motor controls, that position there is at 2. So let's, excuse me. Okay, and now, oop. All right. So we want to add points. And you would add a point, add a point, add a point, add a point. These would be at the locations of cells. The function that it is also being applied, so let's remove this center point. Delete. Okay, and then the rest of these we'll keep. Maybe we'll draw one over here. Add point. Okay, and so it's a log spiral that's going to be drawn, and that's using the galvo scanner. The number of revolutions to go from the middle to the maximum is 5. That can be changed by here. You can change this to 4, 6, 5 is fine. Done. And I would, after I put in some points, click done. And may eliminate the live image. Okay, and then some of the things that I might want to change. This is the size of the spiral bounding box, so let's just make that 30. That's still too big, but it's going to be easier for us to see. And let's make this 0. And let's set this to 0, 2 to 0. Okay. And the duration can be something for cells. You might want it to be pretty quick, so you might want it to be 2. And then for us to see this, we might want to make this 1000. So that would be 2 milliseconds times 1000 be about 2 seconds. I would never use 50% power. I'll start with 1%. I think that's going to be too much. We'll see. I think that's it. That's what we're going to draw. Let me bring this camera back and move this over. Okay, and then what we want to do is click Start. And on this line where it says New Stimulus Group, double click that. And the status line will say Waiting for Trigger. And I should have allow multiple triggers, so let me click on that again. And then here we go. Okay. So that's the result of that. Let's put on a light back there, and let's change this to maybe 400. Okay, just want to be able to see this surface, and then we'd hit trigger again. Okay, and you don't quite see the spiral, but we're going pretty fast, and this is not time resolving it, but we can keep pounding it, and this is not a bad intensity. We're doing a little bit of damage. Let's zoom in on the center one. This is actually not a point, it's the 0 order beam, and I think you can see. Let's get trigger. Still too bright. Trigger. Yeah. Trigger. Okay, so we can attenuate this, or we can go much shorter on the exposure time. So let's try 1 millisecond and go to trigger. Okay, and so we're not quite capturing the full log spiral motion, but that's okay. And okay, I've zoomed out. Trigger. Yeah, so this is rather bright. So we'll just change the scale to trigger. Okay, and you can see the others. All right, so one of the things I see is that it's pretty large. The field of view is pretty large. If I showed you the yeah. Okay, so let me unclick that, and let's go the tile view. Oop. There we are. And we could just move these in. So to do that, we would go to points. Let's move this widget bar out of the way. Click on points. That would give you the individual points, and then you could just, that one, and you could move that in. And I don't think I need to do, yeah, just bring these in. Maybe to just make this a little more obvious. So we got kind of in a line, and then these other two guys out here. Done. come back to here. Let's abort. We have to always abort between changes to the ROI group editor. Click Start again. Double-click the new stimulus group. And then hit Trigger. Okay. So let's zoom in on one of these. Nope. And let's illuminate, which we're doing. All right, let's make this. One of the things is because we don't have a uniform film, it looks a little strange. Let's find a position like this and this, and turn that light down, and then do Trigger. Okay, and then you can see we've burned a nice spot, and you can kind of see resolve the lines, individual lines. So let's do that again. Oop. Okay, and so let's see if we can. What I'm doing is, yeah. Anyhow, you can maybe make out the individual lines. There shouldn't be any frap. This film is pretty stationary, so once you've burned a line, this is going to stay here overnight. I mean, you can come back tomorrow and it would look like this. We would use this phenomena to actually create the alignment for the SLM relative to the resonant galvo. So that's another video. All right. Let me zoom out. I've clearly drawn some other lines or patterns. And that's one there. And I would like to just show what now happens when, okay, so that's all off, and let me turn off the LED. And then we want to do 2-photon imaging of that. Okay, so we've got to turn out the light. And unfortunately, I have to put the, you can see it's pretty light, bright over by the microscope. Okay. Oop. Okay. All right, let us, this is the camera, which we want to turn off. And the ROI editor, and what we're going to do is look at these guys. So let's go focus. Well, the burn mark is not that obvious, so that was what I was going to show. And so I don't see it. But the idea would be that if I had used more power, so I'll tell you what I'll do. We can do this without doing anything other than abort. Just want to turn off the PMTs, and I think I'd prefer not to let the light, so I'm going to take the primary dichroic out, and then I'm going to go down here and change this power to 3%. If we were slightly burning at 1%, 3% should take that up. So let's abort. Start. Double-click New Stimulus. And then trigger. And trigger. And we might even actually, even though the dichroic is in, yeah, that's how bright it is. You can see through the dichroic. Oh, right, I took the dichroic out. So let's see what we see. We got some burn marks, but let's make it a little more obvious. Got a 5%. Abort. Start. Click. And then trigger. 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 Okay, I suppose I could have made this size a little smaller. Abort. Start. Double click. Sometimes I don't double click. The location is off a little bit. And that's because of where the position of the bounding box is located. So there's a setting here somewhere, and I don't remember where. But anyhow, that's okay. So let's go back to imaging. Oop. Turn off. All right. Okay, here we go. I think it's more evident now about what the position of those spots are, and those guys are lined up, and those two were also, and then this in the center here is the position of the zero order beam. And I didn't say it, but we would normally block that. We have a device for picking off that light that goes right along that axis, the optical axis, that is the zero order beam. All right, so that at the moment is the pretty simple setup and simple 2-photon imaging and then pattern illumination.